Page 247. So on Friday, we learned the 3 log rules. We learned product law, which says if you are multiplying the arguments, it is the same as adding 2 individual logs. If you are dividing, it's the same as subtracting. And the power law says, if you have an exponent, you can either move it down, or if it's a number in front, you can move it up. So we're going to continue to use these rules to simplify logs. So we're going to combine them all now. So we're going to skip down to A here. We got 1/2 log base A of 16 minus 1/3 log base A of 8. We need to write it as a single logarithm. If you have numbers in front, you need to get rid of them. So what can I do with the 1/2 and the 1/3? Put it up to the argument, okay? So I get log A 16 to the power of 1/2 minus log A 8 to the power of 1/3. Leave the sign in front. Just take the number, okay? Leave the negative sign here and just take the 1/3 up. Now, you are such experts with fractional exponents. What does a fractional exponent of 1/2 mean? Square root, right? So this is the same as, and if you have a fractional exponent of 1/3, it means the cube root. What's the square root of 16? What's the cube root of 8? If you're subtracting, you are? So you get log base A of 2. Yes?
Just to double check, they have to be the same base.
They have to be the same base to combine them. All right. Is everybody okay with that? All right. If A is equal to 32, evaluate this. So okay, we're going to do this 2 different ways. Which way do you want? Do you want to do it I'm going to call it the cop-out way, which is on your calculator?
I don't have that button.
All right. No? Okay, so let's do it the cop-out way first. You either enter that in your calculator. If you don't have the super smart calculator, how do you enter something so that you can, how do you change it so that you can enter it in your calculator? What 2 bases can you enter in your calculator? ln, natural log, or base 10, log. So we'll change this to base 10. So the argument of the original log goes into the numerator, and you divide by the base of the original log becomes the argument of the denominator. You could do that, or you could do ln of 2 over natural log of 32. Either way, you should get
0.2 or 1/5.
Yeah, 1/5 or 0.2, I guess, if you're putting it in a calculator. That's the cop-out way. Cop-out way. Let's do the clever way. Clever way. How do you do it as a clever way? What are you trying to do here? You change the base, right? So how do I write 2 as a power of 32?
Would it just be as a root?
Yes, you're going to write a root. So the 5th root of 32 is 2. Now, I've done a million of these. That's why I know this stuff. But if you can think of it, it'll help you. So then, that's the same thing, correct? And then because the base is matched, it's just the exponent, and you get 1/5. All right, you can just use your calculator. I'm going to make everyone base X, so you can't enter them in your calculator. You'll figure out a way? Okay. Yes. All right. Are we okay? Going once, going twice. All right, next page. All right, top one. There's a couple different ways to do this one as well. There's always multiple ways to do it. You can either move this 3 up or you can move this 3 down. What do you want to do? 3 up? Okay, so if you move the 3 up, anybody know the answer? Yes. Why is it 0? It will simplify to log 1, or 2 apples minus 2 apples is no apples, right? These are the exact same thing, and you're subtracting them. But if you don't see that, that's fine. You combine them, and since we're dividing or subtracting, we are dividing, which is log 1, which is 0. Okay? I don't care how you do it. If you see it right away, you'll give me this 0 answer. Okay. B. What do we want to do in B? Exponential. You mean move the 2 up? Is that what you're saying? Okay. So you can move the 2 up like this, and you will get so I get that. What's 5 squared? And if we're adding, we are multiplying. So I can simplify it to this. Is everybody okay with that? 25 times 4? What's 25 times 4? What base is it if you don't write a base? So what's my answer? Now there's another way to do it. I'll do it right here. If you look at it, you have a 2 here and a 2 here in front. I can factor out a 2. So I can go 2 times log 5 plus log 2. If we're adding, we are multiplying, so that gives me 5 times 2 is 10. What's log base 10 of 10? 1 times the 2 gives you 2. Okay. C. What do we want to do here? There's a whole bunch of different ways to do this one. Common base? That's what I would do. I look at this question. Every time I get a question and I see it's base 3, I ask myself, could 27 be made base 3? Yes. Can 84 be made base 3? Yes. So change them to the common base. So what's 27 to base 3? So if it's 3 to the 3, like that, it's a lot of 3s. What's 81 to base 3? Which is really just 3 to the 9 over 3 to the 16, correct? Does that make sense to everybody? Yeah, I know it looks ugly. Okay. Whoever said that. Yes. Yeah, I'm going to show you another way to do it. So you have 2 bases that are the same. You subtract the exponents. What's 9 minus 16? -7. So I get 3 to the -7. What's my answer? -7, because the bases match. Okay, that's one way to do it. Here's another way to do it. And again, I don't care how you do it, all right? So what you could do is you can split these up. Since they're being divided, you can rewrite them as a subtraction and go log base 3, 27 cubed minus log base 3 of 81 to the 4th. and then change the base. Okay? And you can drop the 3 and the 4 down if you want to. So you can go 3 log 3, 27 is 3, not 3 squared, 3 cubed. Minus, drop the 4 down, and 81 is 3 to the 4. So then this bitch equals 3. And this bitch equals 4. So you get 9 minus 16, which is negative 7. It's whatever way your brain sees it, I don't care. Okay? Just follow the log rules and I will be happy. Is that okay for everybody? Yes? Okay. We're good? 1 to 3, please. All right. Here's our big long thing. We have to combine this. Are all the bases the same? Yes, they are, peoples. Bases are the little subscripts. If there's no subscript written, what's the base? 10. These are called the arguments. All right? Those are not the bases. The bases are the same. Wait, what? Okay. First thing you need to do is move all the numbers in front up to exponents. So we have to move that one up and this one up. Okay, so we get that. Now you combine them. Anything that is being added goes where? In the numerator. Anything being subtracted goes into the. So we end up. They will. We just have to simplify the exponents, right?
Is that b times b that just like a?
Close.
Is that b times a?
Yeah. Okay. What do you do with the exponents? Make a match. You just subtract them, right? So I can go over here. It's really like this. Like that. So if you make a common denominator, it's like 1/2 minus 4 over 2, which is. Yes. So you could write it like this. Because they have different exponents. You could write it like that, but if they want no negative exponents, you just drop it down. Okay. Is that okay? It's the same stuff we did on Friday. We're just adding a few more layers to it. All right, here's what I would like you to do. Number 4. Maybe I should do, you know what? Let's do one of, let's do 4C together, actually, before I actually assign it. So everybody go to 4C, please. On page 250. Oh, that's too easy, actually. Actually, we'll do 4C. Okay, I'm going to show you 2 ways to do 4C. All right? So there's a quick, easy way, and then there's a more complicated way. Does anybody see the quick, easy way to do 4C? Fraser.
You can just take the top exponents, which is just 1 x minus 7, and take all the ones where you compare.
Because the base is matched. Boom, boom. Right? So the quick way is you could just go, the base is matched, so really it's just 2x plus 1 minus x minus 7. which is x. Well, you could multiply negative in, yeah. But the answer is just x plus 8. Does everybody see that? Okay, if you don't see that, this is the longer way, and this is the way you'll have to do D. Or bases are the same, so and we're subtracting, so what do we do with the arguments? You divide them. So you can write this. I know, but this is the way you're going to have to actually do D. So now, the bases are the same, so we subtract the exponents of the arguments. So it's like this. And then at that point, hopefully you realize that they're the same, so you just get x plus 8. Okay? That is how you're going to have to do D and number 5. So you're doing 4, 5, 6, 7, 8. Yes. Let me just write that down. Back up here. 4, 5, 6, 7. So basically 4 to 8. That's what you're doing. There you go. Tomorrow, I am